Welcome. In this video, we're going to take a look at how we can use this idea that trig values have some interesting things happening at the reference angles to our advantage. So let's take a quick look. In this problem, it asks us to find the function value, actually, given the function value and the quadrant restriction, find the angle. So here we have sine theta equals 0.2812. But it says that theta needs to be between 90 and 180 degrees. So if we type that into our calculator, what are we typing in our calculator? Getting ahead of myself. We need to get rid of sine. How do we get rid of sine to get theta by itself? We're going to take the inverse sine of both sides. Now, in the previous video, we did some of these problems without using a calculator. With a ratio like 0.2812, we're going to be stuck to using it. It's not the numbers from our special right triangles. So when you type that in the calculator, you're going to get that theta is 16.3 degrees, which is great. We've got our answer, right? Oh, wait a minute. That's not going to work. Theta has to be between 90 and 180. So this isn't the theta that we're looking for our answer. So what is going on here? Well, this handy little picture that's going to come up a lot in this section, we're going to use to our advantage. We know that theta is 16.3 degrees. Okay. This is 16.3. Now, we also know that sine is 0.2812. But we also know that something else about sine. What is the definition of sine in terms of x, y, and r? Hopefully you said it's y over r. You would be right. That means that if I look at the y value here, but wait a minute, there's not a denominator. What are we going to do about that? Well, we can make the denominator a 1. So now I can think of y as being 0.2812 and r as being 1. So if this is 1, change to blue. This is 1, then my y value here is 0.2812. Now, for theta to be between 90 and 180, that's going to be in the second quadrant here. But I need to have the same y value in this quadrant as I did over there. So how is that going to happen? Well, we just need to draw a line over from here. We now know that this triangle, maybe I'll keep it in orange, here has the same height, 0.21, no, what was it, 0.2812, as this triangle did over here. And the radius here is the same as this radius, and so we know that this triangle has to have the same angle here as this triangle did here. And so we can find now what is the angle. I'm going to use something darker. What is the angle that's between 90 and 180 that will work? That's this angle right here. So how do we find that angle? Well, we know the whole thing, the straight line, is 180 minus this orange part right here. So it's 180 minus 16.3, and that's going to give us 163.7 degrees. And that angle is between 90 and 180. A lot going on there. Think back to where we started. We started with sine of theta equals this. We then did the inverse sine to get the angle in the first quadrant, 16.3. We then had to find it in the second quadrant. We knew in the second quadrant y over r, we knew the y-coordinate here would be the same as the y-coordinate here. So we knew that angle had to be 16.3. So then we took 180 minus that, because that would give me this part, which is 163.7. All right. Why don't you try part B? If you're not sure how to handle the cotangent, you can watch the next part of the video and then pause it, but try the last part on your own. All right, so let's take a look at cotangent. If we know that cotangent of theta equals negative 0.1611, you might want to put that in your calculator, get the inverse cotangent to get what theta is. The issue is most calculators don't have an inverse cotangent button. So instead, we have to look at tangent of theta being the reciprocal of this. Do you remember how to find the reciprocal of a decimal? You do 1 over negative 0.1611. And so then we know that theta we have to do the inverse tangent of both sides, meaning theta has to be 1 over negative 0.1611, which tells us that theta itself is, type it in the calculator, negative 80.8 degrees. This is great. The problem is it asks for theta that's between 270 and 360. So let's go ahead and graph negative 80.8 on the coordinate grid. So if this is 0, if I'm going backwards, this is going to be negative 90 down here. So that gives us negative 80.8 roughly here. And it wants an angle between 270 and 360, which if we go around knowing 90 degrees, 180, 270, 360, tells us we want an angle that's in this quadrant. So instead of going backwards, we just need to go around the other way to get that angle. We don't have to do quite as much work as we did over here. So here, we're just going to go the other direction. There's two ways of thinking about this. One way is to think, well, I could go all the way around, that's 360, and then subtract, go backwards, 80.8. When I do that, I get 279.2. Or another way to think about it is just to say, hey, let's take this and add 360 to it. So negative 80.8 plus 360. Either way, you get 279.2, and that is between 270 and 360. You see, we're really using that circle and the definitions to our advantage. Number 79 here. There's a couple in the homework like this. Given that sine 41 is this, cosine is this, tangent of this, find the trig function values for 319 without using the trig buttons on your calculator. So, in other words, what's the sine of 319, the cosine of 319, and the tangent of 319? Eventually you'll see some shortcuts, and that's fine, you can take them. But for right now, I'm just going to draw it on the circle here, sine of 41 degrees. It's about here. We've got an x, y, and an r. I'm going to hold off on that for just a minute. I want to find 319 on the graph. Can you find 319? Pause it and give it a try. Hopefully you're thinking, okay, if I go around, this is 0, plus 90, plus 90, plus 90, plus 90 is 360. So it's got to be between 270 and 360. Where exactly is it? Well, we like to have this reference angle. So if I take 360 minus 319, that gives me, oh, this is good. This is good. Why is this good? Because now my reference angle is the same. What does that mean? That means whatever my x value is here, it's the same as it is down here. My y value is the same, it's just negative, and the radius is the same. So Let's go back to that now. X, Y, and R. Sine is 41 degrees, 0.6561. Let's make this a ratio. Instead of looking at 0.6561, let's make it a fraction over 1. So now we can think of my sine as being y over r. We can think of my radius as being 1. And then my y value is going to be 0.6561. Should make that bigger. I'm going to. Which means, what's my y value down here? If this distance is 0.6561, and these angles are the same, maybe it's not quite the same in my picture. Better than my board drawings, though, I would say. This has to be negative 0.6561 because it's going down. Here with cosine, if we make this a ratio, that would be x over r. My x value is 0.7547. What's my x value down here? Well, we said it's the same. It's also 0.7547. What about tangent? Well, it's up to you. You can kind of do nothing with it if you want. Or you can think of this as y over x, but we don't really want x to be 1 here. We would rather use the radius as being 1. So we're kind of ignore this for the moment. Now we need to find sine of 319. Remember, 319 is just this angle here. So sine is y over r. Here's y. My radius down here is 1. So sine of 319 is just going to be negative 0.6561. Cosine is my x value. It's going to be the x value over the radius, which is, x value is going to be 0.7547. Tangent then is y over x, right? So we could take negative 0.6561 and divide it by 0.7547. Go ahead and type that in your calculator. This is pretty cool. What'd you end up getting? Not quite, but almost exactly the same. Negative 0.869. This would round to 4. I'm going to leave it as 3 because you can see that's what we got up here. Now, let's look at that a little bit closer. Why is tangent negative here, but positive here? Well, in the first quadrant, y over x is going to be a positive divided by positive. In the fourth quadrant, down here, y is now negative, x is positive, so that answer is going to be negative. And so we can see that where my y-coordinate originally was positive, now it's negative. My x over r, that didn't change. Y over x, that changed. It's positive here, negative here. So, quick summary, really all these problems in my mind are the same thing. They're just looking at the unit circle, it's finding the y values, x values, r's, finding angles, finding reference angles, thinking them through, realizing that when you have the same reference angle, in this case the x was the same, but the y's were different, although they were the same absolute value. One was just negative, one positive. And just working through and reasoning. And this is really a key idea, these concepts here. I know there's a lot, and you might have to watch the video a few times, but this is the meat of trig and understanding trig deeply. And so encourage you to do that. Let me know if you have questions. I'm glad to help.